Hello everyone, myself Ritesh Sherugar from Mudalkatti Institute of Technology Kundapura. In this video, I am going to explain about my internship project automatic washing machine using microcontroller, which is done as a part of embedded system internship which was provided by MLC Technologies Bangalore. Here is the table of content which outlines the structure of the report. It helps to guide you throughout the different sections of the report. Initially, internship learnings, introduction to microcontroller, objectives of the project, tools and peripherals used for the project, and project demo and as well as the conclusion. Let us start with the learnings. In this internship, we have learned so many things including starting from the embedded system to completion of the project. Let us see what is the embedded system. An embedded system is a system it is a microcontroller based system that is designed to perform a specific task or a function within a larger system. It is a combination of hardware and software, often working in real time. In simple way, we can say that embedded system is like a tiny computer but built into a device to do specific task. It is not like our laptop or phone that can run many apps. Instead of doing it does just only few tasks. Typical components included in the embedded systems. Microprocessor or microcontroller. It is the brain of the system that controls everything. Memory unit. In this memory unit, different types of the read-only memory, random access memory, and flash memory. I/O interfaces. Uh, this is this is input and output interfaces like sensors, actuators, etc. Timers and counters. This will controls the operation. Uh, ti- this will controls the clock pulses of the operations. ADC and DAC for analog signal conversion. Power supply and the communication interfaces. These are the typical components in the embedded system. Let's see the architecture of the embedded system. An embedded system architecture refers to the design and structure of the hardware and the software components that work together to make the system function. It defines how the parts of an embedded system are connected and how they communicate with each other to complete a specific task. Initially, the brain of the uh, the brain of the embedded system called microcontroller. It processes the instruction and controls overall the operation. Memory. This will function as storage for the program code and data. There are two types of memory, RAM and ROM. RAM is random access memory and it will hold only temporary memory used during the operation. ROM is a permanent memory where the programs and code will be stored. Input and output devices. In input side we can see in the structure keypad, sensor, switches. These are all gives the input to the microcontroller which is taken by the sensory feedback or other uh, by users. In the output side we can see display, solenoid, motor to do the operation. Output will do the operation. These all things are connected through the communication channel. The communication channel means through which different components, devices, or systems exchange the information. Communication in embedded system is essential because many embedded systems need to send and receive the data between the different parts. Like sensor should send the feedback to the microcontroller through the serial communication, and it will receive the which uh, which action need to be taken, and this will control by the microcontroller, and the signal will goes to the actuator through the communication channel. So communication channel is essential. Next, come to the embedded C program. Embedded C is a variation of C language optimized for programming microcontroller like PIC, AVR, ARM 8051, like that. Many of the microcontrollers are there. All are using embedded C programs only. In this internship, we have learned many points in embedded C programs like variables, loops, if and switch conditions, functions, arrays and pointers, bitwise operation, etc. We have used these functions for our task in the program wherever it is necessary. Let's see why the embedded C program is much used in embedded systems. Features of the embedded C program. Direct hardware access. It will it will access hardware directly. Interrupt handling, port and pin control, bitwise operation, small and efficient, close to hardware, real-time performance, and this will be used compilers like MPLAB X8, Keel, AVR, GCC, etc. We will write the program in C language and we will convert it into hex format, and we will dump that code into the simulation software to visualize the process. Use of timers. A timer is a hardware peripheral that counts the number of clock cycles or time intervals and performs specific actions when certain conditions are met. It typically works by incrementing or decrementing a value and triggers event at the specific intervals, like every 1 millisecond or every 110 microseconds, every 2 seconds, etc. In this project, we have used a PIC microcontroller. For that, registers to use timers are timer 0 and TMR 1 low, TMR 1 high, TMR 2. For example, if TMR 0 is equal to 0, this will indicates that timer 0 is off. TMR 0 is equal to 1 for timer 0 on. Let's see what is interrupt. Interrupt An interrupt is a special mechanism where the microcontroller pauses its main work and jumps to execute a special function. ISR, Interrupt Service Routine. When an event occurs like timer overflow, external pin change, or USART receive, it is a signal to the microcontroller indicating that an event has occurred that requires immediate attention. When the microcontroller receives an interrupt, it halts the main program to process the interrupt. Key registers for interrupt in PIC16F877A, which is used in our project. GIE, Global Interrupt Enable. PEIE, Peripheral Interrupt Enable. INTE, External Interrupt Enable. INTF, External Interrupt Flag. TMR1IE, TMR1, Timer 1 Interrupt Enable. TMRI. The next is Introduction to Microcontroller. Peripheral Interface Controller PIC microcontrollers are a family of microcontrollers made by microchip technology. These microcontrollers are widely used in embedded system applications due to their simplicity, cost effectiveness, low power consumption, and robust performance. In our project, we have used PIC16F877A microcontroller. PIC microcontrollers are based on Harvard architecture, which separates program and data memory. They are available in 8-bit, 16-bit, and 32-bit families, with 8-bit PIC16 and PIC18 series being among the most commonly used in educational and industrial projects. Key features of big microcontrollers: operating speed up to 64 MHz or more, built-in peripherals like ADC, timers, UART, SPI, PWM, flash memory for program storage, EPROM for data storage, RISC-based instruction set, reduced instruction set computer. It is. This is the PixSimLab board. Here we can see many of the peripherals like LCD display, push buttons, and push button lights or push button LEDs, and buzzers, fans or fan or motor, microcontroller, etc. This this is the PixSimLab software. This microcontroller board image is taken by PixSimLab software, which is used for simulation. Here we will dump the hex file and we will visualize the process. Now let's come to our project, washing machine. Objectives of the project: to design and implement an embedded control system for an automatic washing machine using PIC16F877A microcontroller capable of performing wash, rinse and spin cycles. To utilize embedded C programming to develop software that controls the timing, sequence and logic of different washing machine operations. To demonstrate the use of peripherals such as timers, interrupts, GPIO and LCD display modules in a real-time application. To interface input components such as keypads for selecting washing modes and water levels, enabling user interaction. To control the output components including motor and buzzer based on programming logic and sensor inputs. To implement safety mechanisms such as door opening status ensuring the user and machine safety. To create a cost effective, modular and power efficient system that mimics the operation of a real time washing machine in a simplified prototype form. To gain the practical experience in embedded system development including simulation, microcontroller programming and system integration. Let us see what are the tools and peripherals used in this project. We have used MPLAB X IDE v6.25 version for embedded C programming. In this software, we will code and we will do the C programming. MPLAB X IDE it should be MPLAB X IPE v6.25 loads hex file compiled using MPLAB X IDE. PixSimLab. This software is used for project simulation where we will dump the hex file and we will visualize the process. Peripherals used: keypad switches to take the input from the users, LCD display to display the options and operations, buzzer to indicate the door status and completion status to the user. Let us see how the project is working. Initial condition: after connecting the washing machine to the power supply, we need to power on the washing machine. It means we need to turn on the washing machine. By seeing the display, we can analyze that the switch number 5 need to be pressed to power on the washing machine. The display is saying that press key 5 to power on the washing machine. By seeing this, the display user will came to know that switch 5 needs to press to power on the washing machine. After pressing the switch 5, power on washing machine will be displayed for 2 seconds. Program selection window. After pressing switch 5 screen will display the program selection menu. Here, different types of washing programs are listed. Here, we can see 12 types of washing programs are there. User need to select any one of the washing program. User need to short press switch number 4 to scroll the menu bar to select different types. User need to long press the switch 4 for 5 seconds to select the required washing program. If we want to daily means I will keep the star symbol on daily and I will press the switch 4 for 5 seconds to select daily. If we want heavy means we can place the star as heavy and we can press the switch number 4 for long time long we can long press the switch 4 for 5 seconds and we can select a heavy. Like this system will work. Water level selection. After selecting the particular program, uh, it may be daily, heavy and anything, the screen will change to water level. In this screen we need to select what type of water level we want. This in this screen also we have same options like a short press for scroll the menu and a long press for the selection. Star symbol indicate the current selecting function. If the star symbol is uh, placed left side of the low means low is selected and medium means medium will select like that. We need to select particular type of water level and long press switch 4 to select them. After selecting the water level by the user, the screen will display the start and stop options. In this menu, two options will be provided to the user for the easy and flexible operation. If we want to change the program type or if we want to go back to the home window, we need to press switch 6. Here in the screen it is showing that switch 6 for stop and switch 5 for start. If we don't want to change anything, we will move further means we need to press switch number 5 to start the washing program for further process. If selected washing program and water level is satisfied the user, he can proceed with the further process by pressing switch number 5. Operation indication. After starting the washing machine by the user by pressing switch number 5, LCD will display the message that what type of program is selected and how much time it requires to complete the operation. By this, user will came to know that what type of operation he is selected and how much time it requires to complete. This screen will shows for 2 seconds and after that the process will get started. Washing machine will complete the given task by doing 3 operations. Those are wash, rinse, spin. Each operation will take place within the specific time period. These time periods are set in the program as per the standards. During the operation, the motor will continuously run until the operation will ends. The during the operation also, user can able to control the operation by pausing and resuming. We have provided two switches switch number 5 and switch number 6. Switch number 6 is for pause and switch number 5 is to resume. Completion screen. After completing the operation, screen will display the message that program is completed and please remove the close. This will help to user that the washing program which has set by the user is completed and the work is completed. He can take back his clothes, including the buzzer also will indicate that the program is completed. For 2 seconds, the buzzer will beep to indicate the user. After one more thing, after uh, the program is completed, the screen will again go back to the washing program screen, which was initially which was the main program selecting screen. Door status checking. This is a user safety measure. It will ensure that when the door is open or by the user or mistakenly it got open by during the operation period, the buzzer will indicate continuously turns on by indicating that door is open. In the screen also same, that same will be displayed that door is open, please close the door. Once the door is closed by the user, that the process will start to run where it was stopped. It will resume the process. So we are the end of the session. We are end of the presentation. The conclusion. The washing machine project using PIC 16877A microcontroller was successfully designed and implemented, demonstrating the practical application of embedded system in automating household applications. Then the system controlled various washing cycles such as washing, rinsing, and drying based on the user input using components like timers, motors, and sensors interfaced with the microcontroller. Throughout this project, the key embedded concepts such as GPIO controller, timer configuration, state machine implementation, and user interface handling were applied effectively. The use of PIC microcontroller provided flexibility, reliability, and easy programming, making it suitable choice for this type of automation. I hope we have included all the user requirements to in the washing machine project. So thank you.